Hey guys, and welcome back to the channel. We're still busy with the Packard Bell AMD K6-2 500 MHz. Now I know what some of you might be thinking, oh no, not again, but please bear with me. For my audience that likes a lot older PCs, I have a lot more in store for you guys, including this nice little IBM set that I acquired a couple of months ago, so we'll go treasure hunting over there. It also came with this gorgeous 486 and a whole bunch of other stuff. So for the people who like older stuff, I will have you covered very soon, so please bear with me on this. Now this video took a really long time to make, and I didn't really expect that because the idea was pretty simple. I'm just going to take a couple of 3DFX cards that I had, including the Banshee, and kind of compare them against one another on this Packard Bell PC, just to make sure what would be a good fit for it. And then a nice follow-up video would be to test some other PCI non-3DFX video cards that might make a good fit. But after doing some research and really looking at the numbers that I had with the previous setup, I was kind of disappointed with the overall performance of the Banshee and the Packard Bell. Other people seem to be getting much better scores on 3D Mark, for example. And sure enough, as I started testing with another clone PC that I had here, also an AMD K6-2 CPU, although this one clocked at a lower 400 MHz, I noticed that the system was in fact a lot faster, not only in standard gameplay, but also in these synthetic benchmarks like 3D Mark. You can see that there is a substantial increase in the frame rate of these demos here. And that of course results in much higher scores, even on a lower clocked CPU. Now at the same time I also wanted to see how the Packard Bell would stack up against an Intel based platform like this Dell Optiplex that I have here. So the idea is to also pair up the Voodoo Banshee with this Dell computer, which boasts an Intel Pentium 2 running at 450 MHz, and see how the overall performance of the system is, play some games, run some benchmarks, and do some comparisons. Now I know what some of you guys might be thinking. I mean, this is the Packard Bell tax that you need to pay. You know, a crappy office multimedia PC can never live up to the expectations of a real gamer. But I did want to verify that we are actually experiencing a performance loss, and I also wanted to quantify that loss. So that is going to be the goal of this video. We're going to take the Packard Bell, see how it stacks up against an AMD K6-2, which is clocked a little bit lower, here using this clone PC. And we'll also see how it performs against an Intel-based platform like this Dell machine with an Intel Pentium 2 clocked at 450 MHz. So we'll be running a bunch of benchmarks on these three machines using different drivers, and I'll show you the results at the end of the video. But first, a little word on the tooling that we're going to be using to benchmark the system. First up, we have Quake using the software renderer. We're also going to be using GL Quake to test our Banshee card, the 3DFX and OpenGL. We also have Quake 2, the original version 3.05. There is also an AMD optimized one, which is the 3.20 with the AMD 3D Now extensions. We also have Quake 3 that we're going to be using with the internal benchmark. Same goes for Unreal Tournament, so the city intro demo that we can loop to get a feel on the frame rate. Expandables also has a built-in benchmark, so we're going to run that. And the same goes for MDK2. And then we have 3D Mark, obviously, which will give us a nice score. And also Final Reality, which is a popular demo benchmark tool. Now, not all games have built-in benchmarks or a way to show you the frames per second. Now, for those games, we can install Fraps. Now, this is an application which will show you the frame rate while the game is running. So it gives you a nice little visual somewhere on the top corner of your screen. You can also dump the metrics onto a file, so it's a very versatile tool, and it gives you some additional insights while you are playing the game, which is rather nice. Now the downside is that this doesn't work with the Glide API, so games that use 3DFX cards or the Glide API that don't use Direct 3D won't work. So for that we're going to be using the Glide 2.x FPS overlay. So this is actually a wrapper created by Thomas Pearl, so we're going to be using that. And this gives us a nice insight on the performance of 3DFX based games. And so our journey begins with the Voodoo Banshee drivers. So you might recall that I had some difficulties installing the video drivers for the Voodoo Banshee. I ended up settling with this 3DFX quick install, and this is kind of a modified version of a 3DFX installer that somehow made it work on my system. So I ended up with a working Voodoo Banshee setup on the Packard Bell, so I was quite happy with that. So I did some benchmarking using 3D Mark, and obviously it was a big improvement over the internal graphics card which was in the Packard Bell, but still, I mean, certain parts of the benchmark were still kind of slow, and you could see that the machine was struggling to run it. And this also resulted in a relatively low 3D Mark score, which I was initially happy with, but upon further investigation I realized that this was way too low. And all of a sudden it came back to me. I remembered that, back in the day when I was using this 3D Blaster card, I was actually using the Creative 3D Blaster drivers, not the reference drivers from 3DFX. Now, the 3D Blaster Banshee is basically a reference design board with 16 megabytes of RAM clocked at 100 megahertz, and it should be able to handle these reference drivers, but I couldn't get them installed right off the bat, so I had to resort to this 3D Blaster setup program for the Banshee. And after a reboot, let's do a quick check in the device manager just to make sure that the driver that we are using is in fact the one from Creative Technology and not the one coming from 3DFX. So, time for some benchmarking again. And you can immediately see that there's a big difference. I mean, the benchmark starts at around 30 frames per second, and then it rarely drops below 20, whereas in the previous run, I think 20 frames per second was the maximum. So yeah, definitely a big improvement here on this first benchmark. And the same thing for the first person demo, it runs a lot smoother than it did on the previous run. And obviously this will result in a much better 3D Mark score. Now I know you need to take these synthetic benchmark results with a little grain of salt, but the difference is quite remarkable here. As we scroll through the results, we can see that the new Banshee drivers have a positive effect on the overall performance. Just look at the race game here, 23.5 frames per second versus the 18 that we got previously. Same for the first person shooter. I mean, the difference is quite remarkable. And I mean, that's the thing with benchmarking. You need to keep close tabs on what type of drivers you have installed, how you executed the benchmark. Did you do it right after a reboot? Did you do it after playing games? All of that can influence that. And 3D Mark does an excellent job at keeping tabs on, what kind of driver you use for doing this type of benchmarking. For example, here we can see that the 3D Blaster driver was used, including the version, and we can see that on the other score we can see that the 3DFX reference driver was used. So that allows you to scroll through the results and see what type of software drivers you were using. But the thing that was making this process so difficult on the Packard Bell is that as I scrolled through all of the different results of the benchmark runs that I did, and as you can see, I did quite a lot of them, there was just this huge fluctuation in the actual results, with the exact same hardware. So here I've kind of listed down a couple of runs, and as you can see, it ranges somewhere from 1300 to all the way up to 2200 3D marks, which is quite a substantial difference. And next up we have Final Reality. Now this is also a pretty nice benchmarking tool. It's not only visually appealing and it's very nice to look at, but it also gives you some interesting results that stuff like 3D Mark 99 doesn't give you. You're not only getting an overall score, but you can also really dive into the 2D and 3D performance, as well as the bus transfer rate, which is sometimes important on these types of systems because we are working on the PCI bus here, and especially on these kind of OEM branded computers. It's possible that PCI performance is severely hindered by the fact that there is an internal graphics card already present. And these types of systems aren't typically used with a video card on the PCI bus. And I have seen cases where, You know, these bus transfer rate are very, very low, and you will never get the performance out of your PCI card that you would normally get. But apparently this is not the case here, because these numbers are fairly accurate. We're getting around 50 megabytes per second, which is okay on the PCI bus. Now, another thing you need to look out for is specific 3D drivers, especially for 3DFX cards. For example, when I launched Quake 3, I noticed that I got the following, which is definitely not okay. And this was after messing about with, you know, glide drivers and OpenGL DLLs and stuff like that. And obviously I messed up somewhere here, but I mean, just trying to understand what type of files and drivers are being used by what game is very complex and deserves a video on its own. But definitely here in Quake, there was an issue with the OpenGL glide drivers. And if you take a game like Midtown Madness that you can play using Direct3D, I mean, you didn't saw these weird artifacts at all, and that's because it's using a different set of drivers as the standard glide API that you get with these 3DFX games. So yeah, it's always making sure that you have the correct drivers, that you have the correct combination of drivers. For example, to fix the Quake 3 issue, I had to resort to GL Setup, which copied some drivers back and forth, which allowed me to play the game. So now let's now take a quick look on what kind of games that I used to perform the benchmarking and how I did it. So for Quake, you can just type in time demo demo 1 into the console, and it will loop through a small demo here and give you the final frames per second result at the end of the demo. So this is using software rendering, so I mean, this is probably going to test the CPU performance more than anything else, but I mean, it does give you a good indication on how the system is performing. So in this case, we're getting around, I think, 50 frames per second, which is okay. Now, to test the performance of the video card, you definitely need to have something which uses OpenGL or Glide. So here I'm using GL Quake, and I can execute the same command, time demo demo 1, and it will loop through the same demo. It will look a lot better than it did with the software rendering, and again, you will get a final score at the end. And in our case, this was about 40 frames per second. Now, Quake 2 also has a built-in benchmark. You just need to execute it in a slightly different way. I'm using the version 3.05. In the video options, you can see that you have software rendering, you have default OpenGL, but you also have 3DFX OpenGL. So this will use either the standard OpenGL driver or the Glide driver from 3DFX. We just execute time demo 1. And then we launch a demo map. So we execute the map command, demo1.dm2, which will loop through a demo and again give you a score at the end. And here we were getting about 35 frames per second. Now there's also an AMD 3D Now optimized version of Quake 2. So this is version 3.20. So this will give you some additional video options which are specifically made for the AMD 3D Now platform. So if you scroll through the video options, you will now get a 3D Now OpenGL and 3D Now 3DFX GL. The time demo is executed in the same way. We type time demo 1 and then map demo1.dm2, which will launch a demo map. And as you can see, we get a slightly higher score than the previous run. And Quake 3 has a different way to launch the internal benchmark. So for that, we use the CG_draw FPS1 command to show the frame counter. We execute time demo 1 and then demo 001, which will launch the demo map. And for some reason on this particular run, I got an abysmal frame rate, and the demo concluded with 16.1 frames per second on average. Now, one small note, you can also update Quake from version 1.11 to version 1.32, and you can execute the same time demo by executing the same commands. The only thing is that it will not find the demo 001. So on this version, you need to type demo 4 to launch another demo map. So Game starts and we're getting a fairly decent frames per second, around 30-40 to begin with, but it kind of drops as the demo is moving along to arrive at a final average score of 22.6 frames per second. And that's one thing I noticed when running these benchmarks, and I ran a lot of them, trust me. And that is the fact that these numbers can fluctuate heavily between runs, even if you run them at the exact same time. And this was especially the case with this Packard Bell AMD. I didn't see that on the other platforms that I was benchmarking, so I'm not really sure what's causing that. Now, if that's not high enough for you, you can always tone down the settings a little bit. I noticed that the video mode itself, the resolution, it doesn't really make a whole lot of difference. It's more the detail of the geometries and the textures that make up for a big difference in frame rate. Now, when playing Quake, obviously you want to maximize your frame rate. You don't really care that much about geometry details. And with these lower settings, you get 24.5 frames per second. Unreal Tournament also has an internal benchmark. As you start the game, it will launch the city intro demo, which will just loop forever. You can pop the system console, and when you type time demo 1, you will get this frame counter here on the right side of your screen. And this will just loop forever and ever and ever. And just to get an accurate frame count, you can run this for a couple of times over and then pop the system console, and that should give you a good average frame count of this city run demo. Another game with a built-in benchmark is expandable from Rage. So I've added a shortcut here on this menu, and what you need to do is you need to execute the Go executable and add the time demo 1 argument. So as soon as you launch that, it will detect that it is running in time demo mode, and it will then loop through some gameplay, and it will display the average frame rate. AMD K2 also has an internal benchmark feature. Now, running this is very simple. From the AMD K2 launcher, you can select your OpenGL driver, get some info. You can select a resolution, and then you hit test settings, and it will load up the game and start an internal benchmark where it will display the average frames per second. At the end, you get a nice little pop-up with the final results. So let me just show you how I captured all of these results. I've prepared a Google Sheet here which features 3 different machines. We have the AMD K6-2 400, the clone machine. We have our Packard Bell, clocked at 500 MHz, and I've also added a Dell Optiplex Intel Pentium 2 running at 450 MHz. Now for each machine, I have used 3 different sets of drivers. I've used the creative drivers, and then I have used 2 3DFX reference driver versions, including the latest one, just to get a good feel on what the impact of the drivers has on the overall performance of a given system. So each graph will basically contain 9 data points, 3 for each machine that I have run the benchmarks on. And I've also used 3 different drivers on each machine, giving us a total of 9 combinations. So let's start with a 3D Mark score. On the first 3 bars, you see the results of the AMD K6-2 400 clone PC. 3 different results because we're using 3 different drivers. But as you can see, they're all pretty much the same. We're getting about 2,500 3D Mark score, regardless of the driver on this AMD K6-2 400. Now, if we go to the other 3 bars in the middle, and those are the results of our Packard Bell AMD K6-2 500 MHz, we get a different picture. Depending on the driver which is used, we see a huge fluctuation in the results. And the absolute maximum result that I got out of it was 2,200 using a 3DFX reference driver, which was quite a bit lower than what I got on the AMD K6-2 400, which was a bit of a surprise, obviously, because the Packard Bell is clocked 100 MHz higher than the clone machine. Now the Dell Optiplex with the Intel Pentium 2 450 gets a much higher score as it's able to squeeze a lot more out of the Voodoo Banshee card, but the results are pretty much the same regardless of the driver being used. And we see the same thing with the CPU 3D Mark score, which is another metric from 3D Mark. Again, for the Packard Bell, lots of fluctuations depending on the driver which is used, but relatively flat for the AMD K6 clone and the Dell Optiplex. Another thing you'll notice is that the Packard Bell is actually underperforming when compared to the AMD K6-2 clocked at 400 MHz, which is a bit strange. And also when looking at the CPU 3D Mark, I noticed that the Intel Pentium 2 450 scored on the low side. And here we have Final Reality, which was also a very popular benchmarking tool. You can again see that the AMD K6-2 400 outperforms the Packard Bell, and the Intel Pentium is just way up there. But what's more important again is that the driver selection makes a pretty huge difference in the ultimate score on the Packard Bell, something that you don't see on the AMD K6-2 400 and the Intel Pentium 2. Now let's take a look at Quake and GL Quake. I have three sets of benchmarks here, one using Quake at a low resolution. And as you can see, the AMD K6-2 400 outperforms the Packard Bell again. Obviously, the Intel Pentium 2 is a lot faster. On higher resolutions, the difference is a bit smaller, but we see the same trending. Now with GL Quake, what we see is that both the AMD K6 400 and the Intel Pentium 2 kind of max out at around 70 frames per second, but the Packard Bell is underperforming versus the AMD K6-2 400. And what we also see on GL Quake, so using the 3DFX chip, is that the creative drivers are performing substantially lower on the AMD platform, something that we're not seeing on the Intel platform. Now in Quake 2, we see some fluctuations on all platforms with different drivers. Clearly, the Intel Pentium 2 is outperforming all of the systems, especially in lower resolutions. They kind of all max out at the 800 by 600 resolution. But what we again see is that the Packard Bell is underperforming when compared to the AMD K6-2 400. With Quake 3, it's kind of the same story. I mean, the K6-2 400 runs a lot faster than the Packard Bell, clocked at 500 MHz. And again, at lower resolutions, the Intel Pentium 2 is the faster one of the bunch, whereas on higher resolution, it kind of evens out. Next up, Unreal. Again, same story. The AMD K6-2 400 outperforms the Packard Bell, and the Intel Pentium 2 is obviously the better one of them all, even on higher resolutions. MDK2 also has a built-in benchmark, but I couldn't get this to run with the creative drivers because there was no OpenGL driver in the creative drivers package, so MDK wasn't able to detect that. With the 3DFX reference drivers, we got about roughly the same result on the AMD platforms. Intel Pentium was a lot faster on lower resolutions. And the final chart that I wanted to show you is expandable. And again, same thing. What we see here is that the Packard Bell is completely outperformed by this slower clocked AMD K6-2 400, and the Intel Pentium 2 is just way faster. Now, one thing to note is that I wasn't able to run the game with the latest reference drivers from 3DFX. That's why we only have 2 results per machine here. But I mean, the main takeaway from this video that I get is that the Packard Bell does seem to be slower as opposed to the slower clocked AMD K6-2 clone machine. The Intel Pentium 2 is just in a league of its own. And the Packard Bell is also very sensitive to the type of driver, the type of video driver that you're using. So depending on what driver that you have installed, you will see big differences in the performances of the games, something that you don't see on the other 2 computers. Now, these benchmarks and time demos are really nice, but ultimately it comes down how the system will react when you're actually playing games. So that's also something that you definitely need to check out. For example, here in Midtown Madness, I'm just going to be doing a quick race. I have Fraps 98 running here to show the frames per second on the left top corner. And that gives you a good idea on how the game is performing. And you know, we usually get around 25 frames per second, which is not great. I mean, should be getting like 30 and 40 for an excellent experience, but I mean, this is okay-ish. I mean, something is definitely holding back the system because I think the Banshee would be able to deliver a lot more. even on an AMD K6-2 500 megahertz, you can definitely see the frame rate slowing down as the scenes get a little bit more intense and crowded. But yeah, it's still playable, but I mean, should be able to do a lot better. And Need for Speed 3 is also a fairly, intense game for this type of hardware. So let's take a look at the graphic options we have here. So I'm going to be running this game at 640 by 480. I have everything set to high. So let's see how the game performs. And so yeah, the game starts off really nice at 30 plus frames per second. But I mean, as soon as you start the game, you see that the frame rate drops a little bit. And you should be expecting somewhere between 20 and 25 frames per second on average here using this game. It is playable, but again, it's like it would benefit from 10 frames per second extra. But it is what it is, and it definitely improves the experience from the original Packard Bell setup. I also played some Unreal Tournament, which actually runs pretty well with the Voodoo Banshee on the Packard Bell. Again, I got kind of an average frame rate, somewhere between 25 frames per second. But it's definitely playable. It runs at default 640 by 480 resolution using the 3DFX glide drivers, and yeah, it works absolutely fine. And yeah, after looking at the Quake 3 time demo for about 300 times, I was actually glad to just play a little bit. And again, it had a fairly decent frame rate. I was running it on low settings, obviously, but yeah, it still looks really awesome, this game, and the gameplay is simply phenomenal. So what are my next plans? I am planning on doing a 3DFX video on this machine where I compare these different cards. I think I have enough information now to quickly do that. I also have the PCI cards that I would really like to test on a machine like this just to see how they perform. So yeah, definitely still a lot of stuff to go through. Now, I hope you haven't gotten too sick of this PC by now. I know I had a couple of moments where I was about to give up on it, but I am planning on seeing it through, checking out the 3DFX and the PCI cards. I might throw in another video in the meantime just to show off some older stuff. I'm working on setting up my basement. I have lots of other computers that I still want to show you guys, so yeah, please stick around. Hope you enjoy the content. Please consider subscribing, dropping a comment. Let me know in the comments what you think about this, and I'll hope to see you guys soon. Bye-bye.